In our last module, we focused on t-shirt sizing. The goal there was simple. Make a quick judgment about complexity and route the work to the right place. We weren't worried about cost or schedule at that point. We just wanted to avoid over-analysing small requests and under-managing large ones. But once work has been routed, we do need to begin forecasting. Leaders want to know, how much will this cost? How long will it take? Now, we could try to answer those questions with a very detailed planning exercise, building out work breakdown structures, running critical path analysis, and creating a full baseline plan. But here's the problem. Early in the life of a big initiative, we don't know enough for that kind of precision. And all that effort often creates a false sense of confidence while burning time and energy we could have spent delivering value. Instead, we start with a rough order of magnitude, or ROM estimate. ROM is designed to be fast, empirical, and practical. It doesn't pretend to eliminate uncertainty. Instead, it works with it. We use patterns from our actual flow of work, often captured in tools like a cumulative flow diagram, to say, based on how we've delivered in the past, here's the likely range for this new piece of work. Why is ROM so useful? 3 reasons stand out. First, it's faster. We can create a ROM estimate in hours or days, not weeks. That speed means we can move into conversations about priority and funding much sooner. Second, it's accurate, even if it's not precise. And here, it helps to pause and unpack those 2 words. Accuracy is about whether we're in the right ballpark. If we say it will cost about $1 million and it ends up close to that, we were accurate. Precision is about how many decimal places we use. Saying $1,037,426.83 sounds precise. But if the real number turns out to be $1.3 million, it wasn't accurate at all. ROM accepts a wide band of uncertainty, but it aims to be accurate enough to guide decisions. Third, ROM is often good enough. It doesn't need to give us a perfect answer. It just needs to give us the confidence to move forward. Think of it as the right tool for the right stage. ROM is the early compass heading. Detailed plans will come later, once we've travelled further and know more about the terrain ahead. This brings us to large initiatives, like epics. Epics live inside what's often called the cone of uncertainty. The parts of the epic that are close to us, maybe the first features or stories, are well understood. We can describe them in detail and even estimate them in hours. But the parts further out are still hazy. They might depend on future discoveries, shifts in the market, or technology choices we haven't locked in yet. To deal with this, we divide epics into work packages for the things we understand well, and planning packages for the things that are still too far away to pin down. And here's where a really important principle comes in: significant figures. In science, you can't combine a rough measurement with a highly precise one, and then claim the final answer is highly precise. The precision of your answer is limited by the least precise input. The same is true for epics. If you know hours for near-term work, but have almost no detail on what comes later, you can't claim you know exactly what % complete the epic is. You don't actually know the denominator, the total scope, and pretending you do creates misleading reports and bad decisions. ROM estimation helps us avoid that trap. It respects uncertainty. It lets us acknowledge what we know and what we don't. It focuses on accuracy in the big picture rather than chasing false precision in the details. And most importantly, it gives us just enough information, just in time, to make smart choices about investment, sequencing, and scope. That's why ROM is such a powerful bridge. It connects the lightweight, complexity-based routing of t-shirt sizing with the heavier planning that comes later, giving us a clear, honest picture of what's possible without bogging us down in premature detail. So how do we forecast responsibly inside the cone of uncertainty? Let's turn to a few analogies. Think about shooting at a target. A good marksman doesn't expect every round to hit the exact same hole. Instead, they expect all rounds to fall inside a consistent grouping, their minutes of angle, or MOA, at a given distance. If a shot falls outside the grouping, they're surprised. That's the standard for accuracy. It's the same with a field goal in football. A kicker isn't judged on splitting the exact centre of the uprights every time. As long as the ball passes between the posts, it's accurate. Missing outside the posts is what surprises us. Estimation works the same way. We aren't looking for pinpoint precision early on. We're looking for accuracy within a grouping. ROM gives us that grouping, a reliable range based on empirical system performance. Now, how do we actually create a ROM estimate? This is where the Cumulative Flow Diagram, or CFD, comes in. A CFD shows how work items flow through stages over time, such as proposed, active, resolved, and done. To forecast, we overlay trend lines on that flow. These lines show the rate at which work is completed. But here's the key. We don't just draw a single neat average line. Work doesn't move at a constant pace. There are peaks and valleys in throughput. If we use the average, we'll be wrong exactly half the time. Instead, we forecast using the edges. For schedule, we forecast to the valleys, the slower pace. That way, we don't overpromise and miss delivery dates. For cost, we forecast to the peaks, the heavier burn. That way, we don't underfund the work. This principle makes our ROM estimates accurate, even if not perfectly precise. We also capture a margin of error. With features, the margin might be wide, 70%. With story points, it narrows to around 20%. With raw story counts, it can be as tight as 10%. The scale of measurement matters because it defines the resolution of the grouping. But there's one more watch out: scope stability. If scope changes during the time box, if new work is added mid-flight, our forecasts collapse. It's like trying to kick a field goal while someone is moving the uprights. This is why scope creep is one of the biggest anti-patterns in forecasting. So, the process of creating a ROM estimate looks like this. Choose the right scale for scope items, features, points, or story counts. Overlay trend lines on the CFD using empirical delivery data. Forecast to valleys for schedule, peaks for cost. Define a margin of error based on observed variation. Guard against scope creep, because moving the target destroys predictability. By combining the principle of the cone of uncertainty with the practice of ROM using CFDs, we get forecasts that are fast, empirical, and actionable. They don't pretend to remove uncertainty, but they make it visible. And that honesty is what allows us to make better decisions, sooner, with more confidence. Now, let's look at a few real-world examples of ROM in action. In one case, we saw lead time drop from 8.5 months to just 1.5 months, simply by adding one additional team member. That improvement saved the program 7 months of time every year and about $700,000 in cost. ROM analysis made the impact of that single staffing change clear and measurable. In another case, the opposite happened. RAID items weren't managed, and there was no Scrum Master in place. Lead time jumped from 2 months to 5 months. That slip cost the program 3 extra months annually and nearly $300,000 in added cost. ROM didn't just show us when we would finish. It showed us how inefficiencies were directly draining money and time. We've also seen situations where instability in flow created waste. In April, the team was delivering steadily at a 2-month lead time. By May, it dropped dramatically to just 1 sprint. But in June, it spiked to 3 months. That kind of instability carried a penalty of 2.5 months lost time. and around $250,000 in cost. These examples highlight why ROM is so powerful. It turns empirical delivery data into forecasts that are faster, more accurate, and more actionable than traditional methods. Instead of spending weeks building detailed baseline plans that may never hold, ROM lets us forecast using reality, what the system is actually doing today, and make informed adjustments. We can see the value of staffing changes, the cost of unmanaged risks, and the waste from instability. And that's the point. ROM is not just about predicting delivery dates. It's about surfacing cause and effect in real time so we can act quickly, reduce waste, and maximize the value delivered to our customers. As we close, remember the three essentials of ROM estimation. It is faster. We can forecast in hours or days instead of weeks. It is accurate, not down to decimal points, but reliably in the right range because it's grounded in empirical data. And it is good enough, providing the confidence we need to make decisions and move forward without wasting time on over-analysis. That's the power of ROM. Forecast with confidence without wasting time.